Alrighty, it's time for another statics problem. This is from Exam 1 of Fall 2017. This is problem number 3. So again, like always, we'll start by reading the problem. We have two forces of equal magnitude in opposite direction are applied perpendicular to segment AB at points A and B of the pipe assembly shown. Note that force FA lies in the YZ plane. So part A asks, determine the moment at point B due to the two applied forces. Report your answer in Cartesian form. Part B states, determine the moment at point O due to the two applied forces. Report your answer as magnitude and direction cosines. And then part C says, as viewed from point A, looking towards point O, is the component of the moment about pipe segment OA clockwise or counterclockwise? Okay, that's a lot that we've just read there. There's a lot that we need to do here and a lot about moments, so let's just jump right into part A. So determine the moment at point B due to the two applied forces and report your answer in Cartesian form. Well, the moment at point B, one thing to notice is these forces here would be causing a couple. If you look at them, they're two forces of the same magnitude, 450 newtons, and they're occurring on the same beam, or the same pipe here, and they're occurring in opposite directions. So therefore, if we were to look at this beam and add up all of their forces together, there would be no external force on this beam, but there would be a moment caused by these forces. And so that's what we need to solve for. So if we want to find the moment at B due to the applied forces, I think it's best if we take out our handy dandy equation sheet and look through everything that we have. And we've got a couple options here. We've got moment of a force about point O, which point O could be any point, could be point B in our case. Or we've got moment of a force couple. But either way, the equations are virtually the same. We want the moment is equal to the position vector crossed with the force vector. And so whichever way we want to do it is the way that we've got to do it. So if we look at here and we want the point about B, the position vector that we're going to want is from B to A. And the reason is that the force FA is acting at A, and this force would be the only force causing a moment about point B. Because at point B, this force here would be doing nothing. It's kind of like the analogy I really like to use is if you have a wrench or whatnot, but let's take a look and pretend that B is kind of the bolt. So if you were trying to, if you had a bolt and you wanted to try to loosen it, but you just put a force on the bolt, you wouldn't really be putting anything on the bolt. You'd just be kind of tugging on it a little bit. It wouldn't cause a moment about it. It wouldn't cause the bolt to turn. Once you add some distance to this force FA over here, that's what's going to cause it to turn, because there is enough distance for it to cause a moment about it. So we just need to worry about the distance, or the position vector from B to A, and then the force FA here. So we're going to first write down the equation that we found here, which is the moment about B is equal to, we're going to say RBA crossed with, let's say FA, and we'll put FA into vector format. Now to put FA into vector format, it's pretty easy what we need to do here. We need to take a look, and since FA is in the YZ plane, like they told us, that means the X of FA is going to be 0. So now we just need to worry about FA in the Y and the Z. So we're going to write this out here. And this is going to be equal to 0I. And we're putting this into Cartesian format, just so we can cross with it. So we've got 0I. Now, if we put FA in the Y direction, if you look, it's pointing into the negative Y direction here. So we're going to put a negative sign there. We're going to have 450 as our magnitude. And then here we've got a 4, 5 here. So it's a 3, 4, 5 triangle to get the horizontal, in this case horizontal component, which is along the Y axis, or along the YZ plane. We put 4/5 here, and that's in the J. And then in the Z, or going up, it's going to be positive, and it's again going to be 450 times 3/5 K. And that's what we have for the vector of FA. And so what we're going to do is MB is equal to, we'll write out our little matrix here, I, J, and K. This is how we do cross products. Oh, my bad. We're going to want to find, of course, what the position vector from B to A is. And the best way to do that is to find what these points are. So the point at B, I'm going to write out like this, is in the x direction, we're given it 0.4. In the y direction, it is going to be 0. And then in the z direction, it is 0.3. Of course, those are all meters, but it doesn't quite matter as much here. At A, it's going to be 0 in the x, 0 in the y, and then in the z, 0.3. And that's because it's on the z-axis here, so really the only dimension it can have is 0.3 in the z. So when we do it like that, let's see here. What we're going to want to do is it's essentially going to be the points of A minus the points of B. So we're going to have 0 minus 0.4, 0 minus 0, and 0.3 minus 0.3, which gives us a position vector of negative 0, 0.4, 0, and 0. Which makes sense, because really the only change from B to A is going negative in the negative x direction, 0.4 meters. And so, for our cross product, we're going to have negative 0.4, we're going to have a 0 here and a 0 there, and we're going to write in our FA, which is going to be 0. And let me get my calculator out real quick. And I think it'd be easier if we calculate the 450 into their little components here before we put them into our matrix. And so we're going to have 450 times 4 over a fifth. Now if I were better at math, maybe I could do that in my head, but I can't. For that one, we're going to get 360. We've got to remember that this is going to be negative. So we've got negative 360. Then we're going to do 450 times 3 divided by 5. And that's going to be 270. And that's going to be a positive 270. And that's what we've got for that. And we'll go ahead. I like to draw lines just for these videos to kind of section them off. They might be kind of helpful for you to, if your work is starting to run together in the exam, just for the grader to see it easier, it might help if you section it off with lines too. I would be very obvious with the points that you're trying to make. And by that I mean, like, if you're doing point A or point B and point C, you could do it. I know in the AP test they would say try to run them all together so they don't just check one part. So if you have the work in another place, it might be correct. Kind of as a test grader, I'd prefer if you do the A, B, and C, kind of keep them separate, but obviously we'll look at other places and see if you have the work there. So it all kind of depends on how you like to organize it yourself and what works for you. So how I like to find cross products is I like to cover this up. And so in the I direction, we're going to take this cross with that, but we end up finding out that this 0 times 270 is going to be 0, and then we want to subtract the 0 times 360, or negative 360, but that's just going to end up being 0, and that's in our I. Now when we do this cover-up method, whenever we do the J, we're always going to want to put that in negative just because of the way we're doing it. There's other methods where you wouldn't have to do this negative side and memorize it, but the way that I'm showing it here and the way that I like to do it best, you cover up the J and you cross it like normal, but you have to remember the negative sign. So the first thing we want to multiply is the negative 0.4, and then we're going to multiply that by this 270 here. Oop. Fix that. 270. And then we're going to subtract, and it's going to end up just being 0, because it's 0 times 0. And that's going to be in the J. And then next is going to be the K. And again, we're going to do this kind of thing here. It's going to be positive because we're back in the K there. So we're going to have our negative 0.4 times, put it in parentheses, negative 360. And then that's going to be 0 times 0. So minus 0, and that's in our K. And so when we figure this all out, it's going to be 0i. Let's see here. This is going to end up being positive because this is a negative. This is going to be negative on the inside, but a negative times a negative makes it a positive. So on my calculator here, we're going to do 0.4 times 270, and that's going to give us 108. 108J, and then let's see here. A negative times a negative is going to make the K also positive. And let's see what we got here. It's going to be 0.4 times, should be 360, and that gives us 144 K, and that's going to be Newton times meters. And that should be our answer for part A. Determine the moment at point B due to the two applied forces. Report it in Cartesian form. And we've got it from FA here, but these make a moment. So we really don't have to worry about the distance from here, especially when it's about point B. This force won't cause a moment at B at all anyway, like I said at the beginning. So we'll go ahead and box that so we know that's our final answer. And down here for MB, we are going to have 0I plus 108J plus 144K, and then always remember your units. That's going to be a good few points there if you put your units in there. So that's our part A. Now we'll work on our part B. Let's see here. We want to determine the moment at point O due to the two applied forces. It's going to be the FB and the FA. I'm going to separate this off so the work doesn't run together. So we want the moment about O caused by these two forces here. And report your answer as magnitude and direction cosines. Okay, I'm going to be honest, reading this question, it's kind of a difficult question, at least the way I'm reading it and reading into it. I'm not entirely sure what they're asking, but at this point, if you were in the middle of the exam and not entirely sure what they're asking, you can always skip it and go back and maybe you'll understand it later on. But for the case of here, we're just going to kind of work through it and hopefully that we do it right. My initial thought of what I'm going to do, and probably what I will end up doing, is we're going to do two cross products because we know that the moment about a point is equal to the position vector crossed with the force. Well, we've got two forces here applied at two different places. So I think that's going to be two different position vectors and two different force vectors, and therefore two different cross products. So we're going to have down here, MO is going to be equal to, let's see here. First of all, we can start with this force here. That's going to be position vector ROB crossed with, and that's going to be FB. And I'm going to put these in parentheses, separate them off, plus other parentheses. This is going to be OA, because we want to see where this force is acting here. So OA, ROA crossed with, and then once again, FA. And that's going to be the same as what we found earlier, the same force here. So we want to know what these position vectors are. So that's our next course of business, course of action. So ROB, and this is really easy because O is the origin, so that's going to be 0. It's essentially just going to be the same points as here, as we found up above. So it's going to be 0.4, 0, 0.3, and then ROA is going to be equal to 0, 0, 0.3. That's what we've got for that. And now we want FB. FB we're going to find the same way that we found FA. FB is going to be equal to, and once again, this is just going to be, it doesn't explicitly say, but I think just looking at this picture and how it's drawn and how they only give us the kind of direction triangle in one slice here, they don't give us another angle showing where it's angled, it's safe to assume that this is in kind of not the YZ plane, but in something that's parallel to it. And so we can assume that, let's see, our x component of this is going to be 0. So 0I. And now for the j component in the y direction, we can see it's going in the positive y. So it's going to be positive, and it's going to end up being this same magnitude here, because it's going to be 450 times 4/5 j, and then this is going down in the z, so it's going to be minus 450 times 3/5 j. And I'm going to go ahead and write this out. I forgot to do it up above. We did it later on, but I'm going to write out what this is going to be. But like I said, we're basically kind of reusing the same numbers up here, just different signs. So it's going to be 0i plus what we had, 360j minus 270k. And that's what we have for that. And that should be everything that we need to know for the moment about O here. And so let's see. I'm apologizing if I apologize if the lighting is kind of off in here. I'm in a little different location than I want to be, so it's not quite as ideal as the other, but hopefully you guys can still see what's going on. It might just be a little annoying. Let's see here. This is going to be, I'm going to draw out or write out two matrices. We've got our I, J, and our K. And let me just go ahead and write out another one. I, J, and K. Like having a little space here. And let's start with the first one. ROB, as we know here, is going to be 0.40, 0.3. And FB, as we found here, 0, 360, negative 270. ROA is going to be 0, 0, 0.3. And, oh, my bad. One thing I did here, I wrote FA here. This should be FB. Hopefully that wasn't too confusing. You guys could follow along earlier. FB, we already have that in here. If we want to look at FA, it's up here. It's 0 and negative 360 and 270. That's what that's going to equal. And now we go through and do our cross products. I'm going to do these a little bit quicker than the one I did up above. Hopefully you guys can follow along and know how I did it. But I'm just going to go ahead and do it how I did it earlier, just a little quicker. So 0 minus so we've got that, and then an RK. And that's just one cross product. We're going to go ahead and I can write it out here. I've got space over here for our second one. I'm going to put big brackets around these just so we can kind of differentiate between them. Maybe that makes sense. And we'll go ahead and do what we've done here. So 0 minus 60. Minus in the J. In the J, this is just going to be 0 because 0 is here, 0J plus, and then the K, it's again going to be all zeros, 0, K. And that can be kind of expected because all we had here in the drawing here was just the change in Z here. And so if we look at it in the change in Z, the only thing that would really cause a moment, or the only thing that would have a moment about it, would ideally be the x-axis, just because we've got the y force going here, it'd be causing a moment about the x-axis. Because a moment about the y-axis is not going to happen because we don't have any forces in this direction, and it's either acting perpendicular to it, or it's acting parallel to it, and those don't cause a moment there. And then kind of same thing with the z, it's actually acting on the z, so there's not going to be any moments from that. And so I'm going to go ahead, in one big move on my calculator, I'm just going to go ahead and add all of this together. So in the i's, we have, that's going to be negative 0.3 times 360. I'm going to go ahead and, whoops, there goes my whole setup. Sorry about that. Alright, I think we're situated again. So we've got negative 0.3 times 360, and then this is going to be 0.3 times negative 360. But that makes, these two negatives make it positive, so we're going to go ahead and add that. 0.3 times 360. Oh, it ends up being 0. So you've got 0i. And then all we have to worry about now because these are zeros here. We just have to worry about this one. So we've got, let's see, negative 0.4 times negative 270 should be positive. We've got a positive 108 J, and then over here, 0.4 times 360, positive 144 K Newton meters. And that's actually our whole thing. Now, one funny thing to mention, or that hopefully you guys notice, is the moment about O is the same as the moment about B that we found up above. These are the same values. And yeah, we did all this work here just to find out that these are the same values. It's kind of unsatisfactory feeling, you know. But that should make sense if you really think about it logically. Like I was saying in the beginning, FA and FB, they're the same magnitude forces and they're in opposite directions. That means that they are they cause a force moment. They're a moment couple, so they cause a moment force. And that basically means that the moment all along here caused by these two forces is the same. And that goes for point O down here. So we spent the time to calculate it out. It took quite a bit of time just to find the same thing. And that's okay for me doing it here, but maybe that's a trick that you want to remember for your exam, is that because these are a moment couple, you can remember that they would be equal to the same thing. Now, this isn't quite the answer here. We wanted this in magnitude. So that's really easy. All you do is you use Pythagorean theorem. 0 squared plus 108 squared plus 144 squared. That's going to be equal to, let's get the square root, 108 squared plus 144 squared. That gives us 180 Newton meters. We'll write that in our answer box here. And then let's go through with these are asking for the direction cosines. Basically, if you guys remember from your vector exam, hopefully you do, the direction cosines are going to be each of these components divided by the magnitude. And that's also given on your equation sheet, which I will show you here. This is cosine theta x, theta y, theta z. And you can see it's each part of the components divided by the magnitude. So for cosine theta x, that's going to just be, for the sake of here, I'm going to write 0 over 180. For cosine theta y, it's going to be 108 over 180. And then cosine z, it's going to be 144 over 180. And these don't really need units because they're just going to cancel out units anyway. And ultimately we would be taking the inverse cosine to find the angle, but that's not what this particular question is asking about. So that's part A and B. And then part C is just a really simple, just look at it type of question, but I'm going to explain it a little more thoroughly here. So if we read the question, as viewed from point A looking toward point O, is the component of the moment about pipe segment OA clockwise or counterclockwise? So I'm going to draw a little picture to help you guys visualize it. It says looking from point A toward point O. And so what that kind of tells me is it might help if we redraw this picture here. And this is really if you're not visualizing it correctly. So let's kind of imagine that we took this here and we kind of twisted it up. Of course, the paper doesn't show it, but if we twisted it up so we're looking straight down this z-axis. We'd be looking straight down the z-axis essentially. And we do that all we have to look for is the y and the x-axis, which I'm going to draw down here, y and x. And then this is going to be this dot here is going to be A and O because they're on top of each other. And then it's going to go over to B. And then I'm going to draw here. This is going to be, this little darker spot is the pipe BA. And so we're going to draw on our forces. which looking from up above, they just look like these little 2D things. Now, as viewed from point A, looking at point O, we want to ask if this moment is clockwise or counterclockwise. Well, just looking at it here, we should be able to see that this force here wouldn't be causing a moment at all, but this force out here is causing a moment. It's a distance away from the line that we're looking at. And when it's pushing down this way, it would be going around like that, which means that's going, looks like counterclockwise. Right hand rule would be positive. That's not what it's asking here, but it's just asking clockwise or counterclockwise. We can see that it would be going counterclockwise, so we can put that in here. Now, with a question like that, I don't think it would really require kind of backing it up, especially when it's just 1 point. That 1 point is basically, do you know it or do you not? But this is kind of what I would suggest drawing out or thinking about it if you're not entirely sure. Now, just looking at the picture, maybe you could just look at it and just see how this force would be pulling around it and you'd know. But in case you're struggling, that's the drawing you can draw to help visualize it. But anyway, this is what I have for problem 3 of exam 1 from fall 2017. I did a lot of extra work here. Part of it was because I'm a little out of practice and I just wanted to make sure. But part of it was I wanted to demonstrate for you, in case I was right, that these two forces here are a force couple, and the moment caused by them would be the same anywhere along this entire shape. So I kind of want to draw an analogy real quick, or not an analogy, but another picture of what you might see on this. If you were to look, I'm going to draw like a little 2D picture here. Let's say you're looking at a beam like this, and maybe like a pin here and a roller here, and they just give you a force like that, or not a force, I'm sorry, a moment like that. Well, whether you're adding moments around this point or this point, you've got to remember that this moment here, even if it is applied somewhere in the middle, no matter where you're adding moments about, it's going to be the same moment. So whether you're adding moments about, for the sake here I did A and B, moments about A, you'd have to include the distances for all these forces here, but you wouldn't have to include a distance, it would just be the moment here. And same idea for point B. So that's just something to keep in mind. Hopefully that makes sense, the way that I've shown you the work here and the way that I've talked about it here. Of course, if it doesn't make sense, or if you're struggling with any parts of this problem, or you struggle to see what I was doing or have any further questions, you can always email me, text me, or call me, and I should be able to answer you. But that's all I have for you for this problem. Hopefully it made sense, and hopefully you guys are feeling good for your exam. Good luck studying, and good luck on your exam. Thanks, guys.